Good morning to all. I'm Purgali from IT department, Sri Shanmuga College of Engineering and Technology. Now I am going to present the topic is graph in data structures and algorithms. Let's begin. First, introduction. Basically, first we have to discuss what is graph in data structure and algorithms. A graph is a non-linear data structure which is collection of vertices and edges. So graphs are used to model any situation where entities or things are related to each other in pairs. Example, transportation network. A graph G is defined as an ordered set of V, E. That is, where V represents the set of vertices and E represents the edges that connects these vertices. Here the example. Here we are using the graph here. The nodes are A, B, C, D and E. The edges are known as represent as E and the word V represent as V. That means V of G here A, B, C, D, E and these are all the vertices, and A of G here A comma B edges, one edge, and similarly B comma C another edges, and third one is A comma D, this is another one edges, and A comma D, this is another one edges, and B comma D. So here itself also one edges, and D comma E is one edge, and C comma E is also another one edges. Whenever the edges are connected here itself also, the vertices are called as V of G and edges are called as E of G. That means these are all the basic introduction of graph, and a graph can be directed and undirected. In an undirected graph, edges do not have any direction associated with them. So this is also one kind of scenario in the graph. Next, the graph definition. So that means adjacent nodes. So vertex W is adjacent to V. So if only and only if V comma W and E. So degree of node is also degree of node U is the total number of edges inside the node U. If degree of U is equal to 0 means U does not belong to any edge and that node is an isolate node. And path. A path in graph is a sequence of adjacent vertices, that is P is equal to V of 0, V1, V2 up to Vn. That Vi, Vi plus 1 and V is for 1 less than or equal to I and less than N. So length. A length of a path is the number of edges on the path, which is equal to N minus 1. And a cycle. A path in which the first and last vertices are same. A simple cycle has no repeated edges or vertices. And out of degree of a node. So out of degree of a node, U is the number of edges that originate at U. In degree of node, that means in degree of a node, U is the number of edges that terminate at U. So on degree of U node. The degree of node are written as degree of U is the equal to sum of its degree and out of that node. And representation of graph. There is two representation mode. One is adjacent matrix representation and another one is adjacent list representation. Here, let's start from the adjacent matrix representation. The adjacent matrix is used to represent which nodes are adjacent to another. Two nodes are said to be adjacent if there is an edge connecting them. In a directed graph G, if node V is adjacent node U, then there is definitely an edge from U to V. That is, if V is adjacent to U, we can get from U to V by traversing one edge. For any graph G having n nodes, the adjacent matrix will have the dimensions of n cross n. So in an adjacency matrix, the rows and columns are labeled by graph vertices. An entry Aij in the adjacent matrix will contain 1. If vertices Vi and Vj are adjacent to each other, if the nodes are not adjacent Aij will said to be 0. and this is adjacent list representation. In adjacent list representation of graph, each vertex keep a list of all adjacent vertices. Here we consider one set of graph. We have node A, node B, and node C, node D, and node E. So here 5 nodes we are having. So each node connected with another node. So first the path will be graph will be the edges connect A and B. So A node we consider as A node goes to B. So B's list is not connected. So C is connect with C. So 3 connection from A. So A is connect with B. So that's why we are putting A and B here. And A C is also connection here. So this is all the adjacent nodes for A. So and another one adjacent node is C. So that's why we put in the list pattern A, B, C. And second only let's consider the B node. If consider B node, what is the adjacent node means? That is what are the nodes connected with D, connected with B, that is called the adjacent nodes. So B is connected, 3 nodes are here. One is D and another one is E. So that's why we are for B nodes, we are representing D node and E node. And next let's consider C node. C node is connect with directly which node? That means so C is self node. C is where it is goes only D only. So that's why the representation of node is adjacent node is for C D only. For D node is for it's come from where it goes to from D, that means D to E and D to D and G to A. So 3 nodes are adjacent nodes for D. Let's consider D and D to A one node goes and D to D self node is also present and D is E node is also present. So that's why for D the adjacent nodes are A, D and E. Finally E there is no nodes to from A to other nodes, so there is no node here. So and this is the adjacency list representation. Next, third type of graph, there is undirected graph, directed graph and weighted graph. So here itself undirected one, there is between A and B node is also present here, there is no direction. So simply edges only connected between A and B. So this is called as undirected graph. That is here an undirected graph is graph G is equal to V comma E with the property that its edges have no directions. So these edges are bidirectional. So in an undirected graph with edge W is adjacent V and V is adjacent W. So like this is the formula pattern and that is simply we represent as undirected graph means that means no direction at all. And next one is directed graph. A directed graph is a graph that means with the property that its edges have directions, that its edges have direction, it is called as directed graph. And weighted graph. So weighted graph, it is next one is weighted graph. It's nothing but it's sum of positive non-zero integer values are assigned to each edge and every edges. Then it is known as weighted graph. That means here V1 is one edge and V2 is also another edge and V3, V4, V5, V6 and V7 are all these are all the nodes. So each node has some integer value. So that means some weight represent by this between these edges. So this is called as weighted graph. And next one is, and this is another one example, the directed graph, and this is undirected graph, and here itself the representation of direction from A node to B node. So one of the direction is specification, that is called as directed graph, and similarly undirected, there is no any mark at all between any edges, that is called as undirected graph. And the advantages of graphs, that is it is easy to follow and clearly shows the adjacent nodes for a particular node, and it is for storing graphs that have a small to moderate number of edges. Adding new nodes in G that means graph, it's easy and straightforward when a graph is represented using a adjacency list. Adding a new node in adjacency matrix is a difficult task as the size of matrix needs to be changed and existing nodes may have to be reordered. And this is also one strongly connected graph, weakly connected graph, and complete graph. It's also kind of the types of graphs. It's also. And this is finally the application of graph. And graphs are constructed for various types of applications such as circuit networks, transport networks, and in a circuit networks where points of connection are drawn as vertices and component wires becomes the edge of the graph. In transport network, the stations are drawn as vertices and routes become the edges of the graph. Once we have a graph for a particular concept, they can be easily used for finding shortest path and project planning, etc. So in state transition diagrams, the nodes are used to represent states and the edges represent legal moves from one state to another. Graphs are also used to draw activity network diagrams, and these diagrams extensively used as a project management tool to represent interdependent relations between groups and steps to tasks that have a significant impact on the project. And this is the main applications of graph. Generally, it's a graph is many applications are present, and we are specifying here some of the applications that are circuit networks, transport networks, and transition diagrams, and also activity network diagrams. And these are all the main applications of graphs. And that's all. Thank you very much.